I want to start today with a scenario that I think is going to be painfully familiar to a huge chunk of our listeners.
Okay.
You're scrolling, maybe on Twitter, maybe on Reddit, and you see it. Some lab OpenAI, Runway, whoever, just dropped a mind-blowing new AI video model.
And the Dell video looks perfect. The lighting is incredible. The physics actually makes sense. It's the new shiny thing everyone's talking about.
Exactly. And you get that rush of excitement. You think, okay, this is it. I'm finally going to make that sci-fi short film I've been dreaming about.
Hmm.
So you rush over to the GitHub page, your finger is hovering over the download button, and then you see it.
The system requirements section.
It is the ultimate buzzkill. It says something like, requires 80GB of VRAM, recommended cluster of H100 GPUs.
And you just look at your gaming PC, the one you were so proud of a couple years ago, and suddenly it feels like a potato.
It's the classic hardware barrier. And honestly, it's been the biggest frustration in open source AI for, what, the last year and a half?
For sure. There's this huge gap between what the big guys can run in the cloud and what we can actually run at home.
That is exactly why we're here today. We found a project that doesn't just lower that barrier, it takes a sledgehammer to it.
Oh, okay.
We're diving into a GitHub repository from a developer named Nalexand, and it's called LTX-2 Optimized.
And this isn't just a minor tweak. This sounds like a pretty fundamental rewrite of how a huge AI model thinks about memory.
The promise here is, frankly, wild. We are talking about running a state-of-the-art, synchronized audio and video model on a consumer card with as little as 8GB of VRAM.
Which puts us right in the territory of an NVIDIA RTX 3070, a 4060 Ti, even some of the newer laptop GPUs.
Yeah, these are cards that millions of people actually have. I have a 3070 in my rig right now.
Right.
And usually when I see AI video, I just scroll past because I assume I'm locked out. So our mission today is to figure out if this is real. How do you shrink a model that big? Is the quality any good? And can a normal person actually get this thing running?
Those are the key questions. And to answer them, we have to start with the original beast itself. This isn't a brand new model. It's an optimization of an existing one. We need to talk about LTX-2.
Right, the base model from Lightrix. What makes LTX-2 so special in the first place?
Well, it's a big deal because it's the first really high-profile, open-access, DIT-based audio-video model.
Okay, hold on. Diffusion Transformer. I feel like I see that acronym everywhere now. We should probably unpack that.
We should. Most of the image models we've been using for years,
Yeah.
like Stable Diffusion 1.5, they were built on an architecture called a UNet.
Okay.
And UNets are great at spatial stuff, making pixels look right, textures, that kind of thing.
Yeah.
But they struggle with long-term coherence.
Like in a video where a character needs to look like the same person from 1 second to the next.
Exactly. The UNet might forget what the character looked like 5 frames ago. But transformers, the tech behind ChatGPT, they're built around attention. They're amazing at understanding context over time.
So a DT just smashes those two worlds together.
You got it. You get the beautiful, crisp visuals from Diffusion, but with the contextual brain of a transformer that understands the flow of time.
And LTX-2 does audio at the same time. That seems like a huge leap.
It is. The old workflow was, generate a silent video, then go to another AI to make a sound effect, and then you try to sync them up in an editor.
And it never works. The sound is always a little bit off.
It always looks like a bad dub.
Yeah.
LTX-2 generates them together. The audio and the video are born at the same moment, so the sync is perfect.
That sounds amazing, but also incredibly heavy. That has to take a ton of VRAM.
It does. The original Lightrix model, a full precision version, you'd probably need at least 24 gigs of VRAM. Maybe more.
So an RTX 4090 at a bare minimum, a total non-starter for most of us.
Until Nalexand's fork came along, specifically engineered to squeeze that beast into an 8-gig box.
Okay, so let's get into the how, the magic trick. The source material talks a lot about FP8 quantization. That sounds like jargon, but I'm guessing it's the key.
It is the key to the castle. And it's actually a concept you deal with all the time. Think about audio files. You have a WAV file, right? The huge, uncompressed studio recording.
Perfect quality, massive file size.
And then you have an MP3. The MP3 just throws away a little bit of data your ear can't really hear anyway to make the file way smaller.
Okay, I'm with you.
Quantization is like that for AI models. The original model stores its knowledge using really precise numbers like 16-bit or 32-bit numbers. Think of it as storing pi to 1,000 decimal places.
Very precise and very memory heavy.
FP8 quantization just says, you know what? We don't need 1,000 decimal places. 3.14 is good enough. By dropping that precision to 8-bit, you can cut the memory usage in half or even more.
But the skeptic in me has to ask, does that make the model dumber? Does the video quality take a nosedive if you're rounding off all the numbers?
It's a trade-off, no question. You might lose a tiny bit of sharpness on a distant object, or it might struggle with a super complex prompt, but that's a tiny price to pay.
I guess a slightly less sharp video is infinitely better than no video at all because your GPU crashed.
Exactly. If the choice is slightly softer or a blue screen of death, the choice is easy.
The source also mentions distillation and a file called LTX-2-19B distilled FP8. What's that about?
Distillation is really cool. It's basically a teacher-student method. You take the huge, slow teacher model and you train a smaller, faster student model to just copy its answers.
So the student learns all the shortcuts to get to the right answer.
Precisely. It learns to get to the same visual result in way fewer steps. This repository recommends a distilled pipeline that only takes about 12 steps to generate a video.
12 steps. I'm used to waiting for like 40 or 50 steps for a single static image.
That's the power of distillation. It makes the whole process so much faster on consumer hardware.
So we've got the compressed brain with FP8 and the fast reflexes with distillation. But I'm seeing other files in the repository. There's a spatial upscaler and something called Gemma 3.
Right, this is where the memory management gets really clever. If you try to generate a 4K video from scratch, pixel by pixel, your VRAM would just explode.
Too much data to hold in memory at once.
Yeah, so the strategy is generate it small, then blow it up. The main model generates a lower resolution video first, which saves a ton of memory.
And then spatial upscaler comes in and cleans it up.
Yeah, but it's a separate, lighter model that just makes it look HD.
Yeah.
It's the enhance button from a spy movie.
Ha, right. And the Gemma 3 text encoder.
That's just the translator. It
Oh.
takes your prompt, your English words, and turns it into the math that the video model can actually understand.
So all of that, the model, the upscaler, the text encoder, it all has to fit inside that 8 GB of VRAM. It's like packing for a month-long trip using only a carry-on bag.
It's a very intense game of Tetris. And that's why this repository is so impressive. It packs that bag for you automatically so nothing spills out.
Which brings us to the user experience. Because usually a project like this means I have to boot into Linux and spend an hour typing commands in a terminal.
The dreaded open source tax, yeah, you pay with your sanity.
But this project's README has a line with 3 exclamation points. Windows 11 support.
That's a huge deal. The original LTX-2 was very Linux-focused. Porting this to Windows opens it up for, 90% of desktop users? It's a massive accessibility win.
And they didn't just get it to run, they gave it a face. A Gradio web interface.
Which is critical. Instead of a black command prompt, you get a local web page with sliders and buttons and checkboxes. It feels like a real application.
And there's one feature in there that I think is just genius. It's called Smart Safe Mode.
Oh, I love this. It shows the developer actually uses their own tool and understands the pain points.
Explain to the listener why this matters, because safe mode sounds kind of boring.
Well, in AI video, you're constantly fighting out-of-memory errors. You try to make 100 frames, crash. You try 90, crash. You finally get 80 to work. Then you change the resolution and 80 crashes again.
It's just endless trial and error.
Smart Safe Mode does the math for you. You pick a resolution, and it calculates the absolute maximum number of frames you can generate before you hit that 8 GB wall. It literally stops you from choosing a setting that will crash your computer.
It saves us from ourselves.
It does. It guarantees a successful generation every single time.
Speaking of which, we should probably manage some expectations. This is running on mid-range hardware. What's the reality here? I'm not making a feature film in 5 minutes, am I?
No, not at all. The performance data in the source, tested on a 3070 Ti laptop, is very honest. You're looking at around 300 to 415 seconds per generation.
So, about 5 to 7 minutes.
For one clip, yeah.
That's a go make a coffee break, maybe even a fold the laundry break.
It is, but you have to put it in context. You're generating synchronized audio and video on your own hardware for free. A cloud service might do it in 30 seconds, but you'd be paying for every single attempt.
And those cents per generation add up to real money really fast when you're experimenting.
Exactly. This gives you unlimited free experimentation if you have the patience.
And what about the length of the video? What can I actually make?
Well, the memory limit is still a hard wall. The source has a table. At 1280 by 704 resolution, which is basically 720p, you can get about 177 frames.
Okay, so at 24 frames a second, that's a little over 7 seconds.
It's roughly 7 seconds, yeah.
Oh.
It's enough for a short clip, a little micro story.
But if I get greedy and try to crank it up to 4K...
Oh, boy. Yeah, if you push to 4K, that Smart Safe mode is going to cap you at 17 frames.
17? That's not even a full second of video.
It's basically a moving photograph. So realistically, you're living in 720p land with this setup.
Which is fine, honestly. If the story's good, 720p is perfectly watchable.
And you can always use other AI tools to upscale it later.
Okay, so let's say we're set up, we've accepted our 720p fate, and we're ready to wait 5 minutes. How do we direct this thing? Prompting for video feels like a totally different skill than prompting for an image.
It is, and this is where most people get it wrong. They just type a cool cyberpunk city and get a static shot where nothing moves.
Super boring.
The LTX-2 docs say you need to adopt a cinematographer mindset. You're not just describing a scene, you're writing a shot list for a camera crew.
Okay, give me an example. What's a bad prompt versus a good cinematographer prompt?
Bad prompt. A woman walking in the rain. The AI has no idea what to do with that. Is it a wide shot? A close-up? Is the camera moving?
So you just get a weird, blurry mess.
Right. A good cinematographer prompt would be something like low-angle shot, camera dollies backward, a woman in a red trench coat walks confidently toward camera. Heavy rain splashes on pavement. Neon lights reflect in puddles. High contrast lighting.
Wow, okay. You're describing the camera's movement, the subject's action, the environment, the lighting, all as separate instructions.
You have to be literal. You're the director. You have to spell it out.
And to help with that, this optimized version has support for lores.
Low-rank adaptations, yeah.
I see them in the UI as checkboxes. Camera control, dolly in. Jib up. Canny control. This seems like it takes the guesswork out of it.
It's a huge help. Instead of just hoping the model understands the words zoom in, you just check the dolly in box, and it forces that specific camera math onto your generation.
Jib up.
Yeah.
That makes me feel like a real filmmaker.
It gives you that granular control. And canny control is really useful too. It lets you upload a reference image, and the AI uses the edges from that image to structure the video.
So I could draw a stick figure, and it would make the video follow that stick figure's pose.
Essentially, yes. It's amazing for consistency. You're not just rolling the dice anymore. You're providing a skeleton for the model to build on.
This really does sound like a mini production studio running on your desktop.
All on a graphics card that was designed to play video games. It's pretty incredible.
Let's just touch on the installation one last time. It's not a one-click install, right? We need to be real with people.
We have to be honest, yeah. It's not an .exe file you just double-click. You need to be comfortable opening a command prompt.
The black box of doom.
You have to make a models folder. You have to download these huge Save Tensors files and put them in exactly the right place. It's a bit like assembling IKEA furniture.
If you put the screw in the wrong hole, the whole thing falls apart.
Perfect analogy. But once you run that python weeb2.py command and that web address pops up, you're golden.
And when you're in, you have to pick a pipeline. There are a few different ones.
Right. For most people, you'll just want the TI2 Thesis pipeline.
That just rolls right off the tongue.
I know, right? But that's the one that does the generation and then the upscaling. That's your high-quality production mode.
And the one-stage pipeline is for quick tests.
Exactly. It skips the upscaler, so it's faster but blurrier. That's your draft mode. The other one, iChlora pipeline, is for image to video or video to video stuff.
It's incredible that this is all just out there for free because one person decided to spend their time optimizing it for the rest of us.
That's the beauty of open source, isn't it? They see a wall, so they build a door.
So what's the big takeaway here? LTX-2 optimized. It's a little slow. It's 720p. It takes some setup. Why is this such a big deal?
It's a big deal because it represents a shift in ownership. For the last couple of years, high-end AI video has been a rental service. You rent time on Runway's GPUs, or you wait in line for Sora.
And you play by their rules, their content filters, their pricing.
Exactly. This project brings that capability home. It moves it from the cloud into your living room. You can experiment, create, and fail privately without a credit card meter running.
And that freedom is everything. If I'm paying $1 for every attempt, I'm going to play it safe. I'll make a beautiful sunset. But if it's free, I might try something weird.
And that's where the interesting part happens. When the cost of failure drops to zero, creativity just explodes.
It also makes you think about the speed of all this. This optimization came out so quickly after the main model was released.
The gap between state-of-the-art research and running on a gaming PC is getting shorter every month.
So I want to leave the listener with this final thought. We've spent this whole time geeking out about VRAM and FP8. But if you zoom out for a second,
Okay.
if one person in the community can shrink an enterprise-grade model to run on a laptop today, what does that mean for 6 months from now?
That's a very provocative question.
Are we getting to a point where the hardware bottleneck just it evaporates. Where any filmmaker with a decent laptop has a Hollywood-level visual effects studio running locally, completely offline.
I think we're closer than most people realize. The software is getting smarter faster than the hardware needs to get bigger.
It completely changes what it means to be an indie creator. The tools are here. The optimizations are here. Now it's just up to you to clear some hard drive space and figure out what story you want to tell.
And maybe invest in a good cooling pad for your laptop.
Couldn't hurt. Thanks for diving in with us. We'll see you on the next one.
Take care, everyone.